chapter 17, Maths IGCSE. Without much ado, let's begin quickly. And today's chapter is graphs in practical situation. First, let's take a look at conversion graph. Conversion graphs, what are they normally used for? Sometimes they are straight line graphs that are used to show two quantities, relationship between two quantities. Okay, they are straight line graphs that depict relationship between two quantities. Okay, usually for conversions of units, let's say for example from degree Celsius to degree Fahrenheit, from Kelvin to degree Celsius, or even for converting currency from dollar to pounds, euro to rand, ringgit to naira. So these are graphs that are used to demonstrate. Not only for conversion purposes, they are used as travel graphs showing the distance relationship between distance and time. Okay, so but the first segment we want to look at are the conversion graph. The first one, conversion graph. What this depicts is showing you how we can convert currencies from one unit to another, from one unit to another. Now let's take a look at this graph. You see, the graph below converts South Africa rand into euro based on an exchange of what? 1 euro equals to 8.8 rand. So what this tells you, every 1 euro you get 8.8 rand. So if you have 10 euro, you go to multiply this by 10, so which means it will be 88 rand. If you have 20 euro, you're going to be like 88 times 2, which will be 160 or 170 something rand. So, but how do we do that with graph? You know, we can do it a simple way in mathematical concept. 1 euro, you say 1 euro equal to 8.8. 1 euro equal to 8.8. Now they say 100 euro. You say 100 euro convert. If you have 100 euro, how much rand, South Africa rand, will you get? So you can like do a simple mathematics. You cross multiply. You say this one you don't know what it is. You can call it x, and then you can cross multiply, right? You can multiply the left side by the right side. Okay, 1 times x, you get x. 8.8 times 100. 8.8 times 100, we get, so meaning we shift this decimal twice, we get 880. We get 880. So you get 880 rand. This is how much you get in South Africa currency. If you take 100 euro, if you take 100 euro, you get 880 rand South African money. So this is from the mathematical calculation point of view. But using graph is simpler. When a graph is already plotted, it's simpler. The problem comes easier. Now let's take a look at using graph. It's a 1 euro. This x-axis is representing the euro. You can see here euro. And why the vertical axis, the y-axis is representing rand. Okay? So 1 euro, you can trace to the graph. So 1 euro, how much? You get 8.8. If you trace to this side, you get 8.8 approximately. Okay? You get 8.8, which is almost 9, right? So that's what you get. 1 euro gives you 8.8. 2 euro will give you trace. You just trace it. You read this one to this graph where it touches the graph. Then you bring it to this other side. You bring it here. Okay, you'll be getting 70 point something, right? You get it 70 point something. So that's what it is. And at the same time, not only euro. If you have 10, you trace 10. Look at 10. 10 euro. You trace 10 euro. You get 88, right? You trace it to this place, and then you trace it back. Let's use highlighter. Now, if you have this one, 10 euro, you see you're going to have 10 euro like this. You trace it to the graph. So once this graph is easy, then you bring it this way. 10 euro will be 88, right? 10 euro will be 88 rand. To be 88 rand. That's what you get, okay? So that's what you get. So it's easy. Not only euro to rand, also you can have rand, you convert to euro. How do you do that? Let's say, for example, you have 70 rand. You want to convert to euro. Let's say we want to convert 70 rand to euro. Okay? Now let's take a look at that quickly. We have 70 rand. We want to convert to euro. So you come here, you come to the axis of the rand, right? You trace it to the graph. You trace it to the graph. Trace this one to the graph, okay? Okay, you'll be straight, okay? We can use ruler to ensure you are moving with broken lines. you move it on the straight path. You trace it to this line graph, and then when you reach the line graph, then you trace it down. If you want to see how much euro you're going to get, trace this one down. How much euro you're going to get? You're going to get 8 euro. Okay, which means 70 rand, South Africa rand, gives you what? Gives you 8 euro. Gives you 8 euro. Assuming the exchange rate is 1 euro equal to 8.8 rand, assuming that this is the conversion unit. Okay, so this is how to use the graph. Okay, so this is how to use the graph. So we move on, and every currency, once sometimes they will not plot the graph for you. They will ask you to plot the graph. So what you do, you already know 1 euro is 88. 2 euro is what? 5 euro is what? 10 euro is what? Okay, you bring those key values out, then you plot the graph. You get a straight line graph like this. Sometimes you have to plot the graph yourself, okay? Sometimes they plot the graph for you, and you use it to answer questions, okay? So that's that for that. If you take a look at this, there are questions that should be answered. Say, using the graph, estimate the number of rand equivalent to 5 euro. Now you take 5 euro, you come 5 euro, you trace it, see 5 euro, you trace it to the graph, trace it to the line graph. Okay, look at the line graph. It reaches here at this junction, this point. So when you reach here, then you trace it to the vertical side. Sorry, here. Then you trace it to this vertical side. That will give you 40 something, maybe 42, right? Or 44 rand. So you get 44 rand. Is that okay? So that gives you around 44 rand. Okay. Okay, but you know, if this graph is a proper graph, it's easy to, your graph paper, it's easy to get the accurate numbers. Okay. The second question says, using the graph, find the cost in euros of a drink costing 25 rand. Now we go to the rand side, which is the vertical. 25, yes, 25. That's halfway between 20 and 30. That's 25. So you trace 25, trace it to the graph. Where it meets the graph, line graph, then you trace it down. That's almost 2.8, 2.9, right? Almost 3 euro. 2.8, 2.9 euro. Okay, that's 2.8 euro. That's 2.8 euro. Is that okay? Okay. Now, if a meal costs 200 rand, use the graph to estimate the cost in euro. Okay, but the graph is not extended to 200. You can even use calculation. Okay, or you can check for 100. 100 will be what? Trace 100. To extend the graph a little bit, you trace 100, or you can even do 50. 50 is what? 5 point what? 50 is 5 point what? Then you multiply the answer by 4, because to reach 200 is 50 times 4. So you trace this one down, multiply the answer by 4. Another trick. Since the graph is not up to 200, or if the graph is up to 100, you want. So here you've been asked, so you have to plot the graph for this one. I think the graph is not plotted. You pause the video and do all this question. Now, it says, given that 80 kilometers equals to 50 miles, this one is between kilometers and miles, units of distances. Okay, kilometers and miles. Draw a conversion graph up to 100 kilometers. Okay, you can put kilometer on the vertical axis and put mile on the horizontal axis. So you already know the simple unit. 80 kilometers equals, so what will be 1 kilometer be? So you have to do that. You have to obtain the simplest unit. 80 kilometers is equals to what? Is equals to 50 miles. Is equals to 50. Right? Which means 8 kilometers equals to 5 miles. Right? That's what it means. Because if you divide it by 10, you get 8 kilometers. 8 kilometers will be 50. 8 kilometers will be 50 miles. Sorry. 8 kilometers will be 5 miles, not 50. Okay, what will 1 kilometer do? 1 will be 5 divided by 8, right? So 1 will be 5 divided by 8. So you get for different value, for double of this value, for 8, for 10, for 15, for 20, so that you can plot the graph. You get the values, then you plot the graph. Is that okay? So pause the video, do all of this question. Now let's go to the second one, this speed, distance, time. If you're a science student, this is pretty much easy. You already know this speed, distance, and time relationship. We know distance is what? Speed times time. Because this one we use a triangle. You know, we use a triangle to depict this formula. We use a triangle to depict this formula. We say speed is equals to distance over time. We say speed is equals to what? Distance or total distance over total time. Speed is equal to total distance. Distance will be what? Speed times time. Distance will be speed times time. They're both horizontal, so you're going to multiply them. This distance is speed multiplied by time. If you're looking for speed, speed is distance over time. Speed is distance over time. Then if you are looking for time, time is distance over speed. Time is what? Distance over speed. So these are the three concepts. Now let's move on, because these ones most of you already know from physics, and then any question that is given, we are able to calculate, right? So since we know the formula, we're able to calculate. Let's take a look at one example as fast as we can, knowing the formula already. It says find the average speed of the object moving in 30 meters in 5 seconds. Okay, so you want speed. We already say speed is what? Distance over time. Speed is meter per second. So our speed is 6 meters per second for this particular question. 6 meters per second for this one. Okay, so you pause and do all of these questions. These are in kilometers per hour. So you're going to do this one. The unit will be kilometers per hour. You say 400 divided by 2.5. 30. Remember 30 minutes is half an hour. So it's 0.5 hour. So you change this one to 2.5. This 2 hour 30 minutes means 2.5 hour. So it can be represented as 2.5 hour. Why? Because 30 minutes means 30 over 60 if you are converted to hour. 30 to 5 seconds. So this one is 5 seconds. This one, the solution is 5 seconds for time. This one, you're going to divide 2 kilometers by 30 kilometers. You get the time here in hours, okay, which you can convert to minutes or seconds. Okay, this 200 centimeters, since this is meter per second, you have to convert this 200 centimeters to meter to be 2 meter. So this will be divided by what? Divide by, if you are converting to meter, divide by 100, right? So you get 2 meters. 2 meters divided by 0.4, you get the answer of this one for time, and so on and so forth. So pause the video and do all of these questions. Now let's go to travel graphs. Now travel graph is similar to what we just said. It has something to do with what we just said. It's like you're plotting the distance in the vertical axis against time on the horizontal axis. Okay, and the gradient is the speed. The gradient is the speed. So the gradient is the relationship or the ratio, the relationship between the vertical distance traveled or the vertical over the horizontal, which is time. So the vertical, if you take 2 points, if you choose 2 points, the gradient will be the vertical relationship, the distance between these 2 points in the vertical orientation, divided by their distance in the horizontal orientation. That gives you the gradient. And the gradient in the distant time graph, the gradient is equal to speed. The gradient is represented by m is equal to what? Speed. Is equal to speed in a distant time graph. Okay, for a travel graph, then for speed time graph, the gradient is equal to acceleration. Okay, but let's focus on distant time graph first. Okay, now we take a look at this. We have the distance plotted 0, 10, 20. An object traveling at a constant speed. An object traveling at what? Constant speed. What does that tell us? It says the object is traveling at a constant speed. What does it say? What does it mean? It means the rate of change of the rate of change of distance travel is constant. Okay? Now from the graph, calculate how long it took to cover a distance of 30 meters. How long is time? How long is time? So you go to 30 meters, trace it, trace 30 meters. You go to the graph, trace 30 meters, trace 30 meters to the line graph, and then trace down. You know the time. Okay, if the graph is already plotted for you, you get 3 seconds. You get 3 seconds. So 3 seconds you have covered. If anyone you want, you just trace. For 80 meters, you trace this one. For 80 meters, how long it took for 80 meters, you trace this one to the graph and trace it down. Trace it down to the time axis. That's 8 seconds. It took you 8 seconds to cover 80 meters. Okay, that's the first question. Now let's go to the second question. Second question says calculate the gradient of the graph. Calculate the gradient. If you want to do gradient, you can use the whole line. That's the bottom and the top, or you can choose any other 2 points. You can use the bottommost on the topmost. Okay, point. It's up to you. But gradient, or you choose any 2 points. You can choose here and here, or here and here. You can choose any point For them, they choose this point and this point. Okay, it's up to you. But choose what is convenient for you. You see, when you choose here, you already have 80. If you choose here, that's 40. So gradient, remember gradient M is the gradient M is equal to the change in the distance, change in y, over change in x, or change in time. Okay, this change in x, change in the time. We are saying the change in the distance axis, which is the y-axis, over change in time, which is the horizontal axis. So what this means is like you're saying d2 minus d1 over t2 minus t1. Okay, it's like you're saying d2, which is same as say y2, this one. Why I'm using d to show you that it's distance, and why I'm using t to show you that it's time. Okay, but it doesn't matter. It doesn't matter what symbol you use, but what matters is that you know exactly what we do. Now, here I want to use the top and bottom to show you that the answer is ordinarily supposed to be the same. So the top is 80, so I'll say 80 minus 0. I use the topmost and the bottommost on the y-axis. So the topmost on the y-axis is this. Over, trace it down. Trace the topmost point down to the horizontal axis. You get 8. And then the bottommost is also 0. So you say 8 minus 0. Okay, we're supposed to get the same answer even though we use different points. So 80 minus 0, you get 80. You get 80 minus 0, you get what? You get 80. 80 over 8. 80 divided by 8. 8 minus 0 is 8, so you get this. So 80 divided by 8, you get 10. You get 10 meter per second if it's in meter. Meter, the vertical one, and the horizontal one is in seconds. So your gradient is 10 meters per second. Is that okay? Your gradient is 10 meters per second. Speed at which the object was traveling, and that's where you now write 10 meters per second. The speed is 10 meters per second. Is that okay? The gradient of the graph. The speed is the gradient of the graph, which is 10 meters per second for this start time graph. Now let's move on. Here are a lot of questions. You pause the video, solve all of this. They're very easy. They're not big deal. Even with these graphical ones, solve them. This one is Johnny A, Johnny B, or Car A, Car B, you know, and you should be able to do all of these questions. Okay, pause the video and solve all of these questions. Let's move to the next sub-unit. Now let's see more problem for maybe two cars moving on the road. What is their concept and so on and so forth. Now, it said the journey of two cars, X and Y, traveling between A and B are represented on a distance time graph on the right. Car X, this is car X, start at 7 a.m. Okay? And then car Y start at 9 a.m. But they reach both at 11, they both reach the same place. At 11, they reach their point B. Right? Okay, at 11. See, he said on the distance time graph, car X and car Y both reach point B 100 kilometers from A, 100 kilometers from point A, meaning point A is anywhere on this point, anywhere. 100 kilometers from A at 11 o'clock, at 11. Okay, so it's a.m., okay, 11 a.m., even though it's in 2400 hours. Okay, so at 11, both of them, they reached the same place. But they didn't start at the same time. Remember, car X started the journey as early as 7 a.m., while car Y started at 9 a.m., and they reached the same time. Why? Because car X, probably maybe the speed was not, at the beginning the speed was great. It was steeper than this. The slope is steeper than this. And then after he got here, he parked, and the speed was not so high again. It's not as steep. The gradient is not as steep as the first instance. So he traveled from 9 to 11 with a very slow, steady speed. But car Y, when he started at 9, he moved at a constant speed that is great. And he reached within 2 hours, he reached where he was going. So this one took 4 hours. Car X, speed of car X between calculate the speed of car X between 7 a.m. and 8 a.m. So between 7 a.m. and 8 a.m. here. So they want us to do the speed. Meaning what you need to do, since it's a distance time graph, if it's a speed time graph, the gradient will not be speed, the gradient will be acceleration. In a speed time graph, the gradient, you did this in physics, the gradient will be acceleration. But since it's a distant time graph, the gradient will be what? Will be speed. So we are going to calculate this one. We're going to do, let's change the color since they also use the same color here. Let's change this color. Okay, since okay, so we're going to calculate this gradient. We're going to calculate this gradient to find the speed here to here from 7 to 8 a.m. So what's the gradient? Here is what? 60. You trace it here, you get 60. 60 minus 0 over 8 minus 7, which is 1 hour, which is 1. So this is in kilometer, this is in hour, kilometer per hour. So the answer is 60 kilometer per hour. 60 kilometer per hour. So that's the speed of car X between 7 and 8 a.m. Between 7 and 8 a.m. That's the speed with which, look at it here. That's the speed with which the car was moving. That's the speed with which the car was moving, right? So that's the first question. The speed of car X between 7 to 8 a.m. So that's how we calculate the speed. The distance traveled, the vertical distance from 7 a.m. to 8 a.m. If you trace the 8 a.m. up here, you see this point. You bring it here, that's 60. 60 minus 0, because you have to do change in y over change in x, or change in the distance over change in time, which is 8 minus 7, which gives you 1. So you get 60 kilometers per hour. The second question says, calculate the speed of car Y between 9 a.m. and 11, the speed. So we're just going to find the gradient of this line, of this line, this green line. We're going to find the gradient, okay? So what it means is that we trace this one, you get 100, right? You say 100, you trace the bottom, you get 0. So 100 minus 0 is 100. That's how they got this 100. Okay, 100 minus 0, you get 100 over 11 minus 9 for the time axis. That's 2. Speed of 50 kilometers per hour. For 2 hours, he was moving at this constant speed, car Y. He didn't change speed. He was moving at this constant speed. So it took him 2 hours. However, car X first was moving at a higher speed of 60 for 1 hour. After that, he stopped for another 1 hour. After that, he moved at a lesser speed. If we want to calculate this gradient, we can also calculate 100 minus 60, that's 40 over 2, right? 40 over 2, 20. So between this place, it was moving, car X was moving at 20 kilometers per hour. You see how slow it was. Now the next question says, explain what is happening to car X between 8 a.m. and 9 a.m. Look at car S. When it started from here, it reached here, and then at 8 o'clock, it parked. You know, when you have a horizontal line in distant time graph, it means you are resting. It means stationary. It means you are in a stationary position in one place. So between 8 a.m. and 9 a.m., you say the car is stationary. Car S was parked, was stationary. Okay? Was stationary. That's what is happening. That's that for this question. So we solved this question. There are many questions like this in the graph. If you're a physics student, these are walkover for you. These are easy. So you pause this video and solve all of this. Okay? The more you do, the better you become. You don't do, you don't get to know. There's no magic. There is no any other way than for you to always solve questions. The more you solve, the easier Cambridge IGCSE is for you. If you skip all of this, you are not solving and waiting for the diamond minutes, it's going to like you're going to compound your problem. Now let's go to speed time graph. You know we just finished this start time graph. Remember I said the gradient of a speed time graph, what does it give you? It gives you acceleration. It gives you what? Acceleration. You know why? Remember from acceleration formula in physics, acceleration is the rate of change of velocity. So final speed minus initial speed, that's change of speed over change of time. This is what we call rate of velocity. Acceleration is rate of change of velocity. So whenever you do a gradient of acceleration, you're going to get a gradient of speed, time graph, you're going to get acceleration. And the distance traveled is the area under the graph. For speed time graph, there are two logics. You've done this in physics. The distance traveled in a speed time graph is the area under the graph. If you want to know the distance, because there's no distance in a speed time graph, right? They are plotting speed against time. They are plotting speed. So for this one now, this is a distance time graph. So whatever they're going to ask you is a distance time graph. From here to here you are parked. But in a speed time graph, when you have something like this, a horizontal line, it's not stationary. It's not resting position. It's called constant speed. It's called you're moving at a constant speed. Okay? So those are the difference between distance time graph. If it's a speed time graph, you calculate the area and then you get there. You get there. The area under the graph, then you get the distance traveled. Now let's take a look at this. This is a speed time graph. Let's take a look at this question. Say, the graph shows the speed of a car over a period of 60 seconds. The graph shows the speed of a car over a period of 60 seconds. So you can see, starting from the beginning, it moves with a steady speed, and then start moving at a constant speed, and then it decelerates. The car decelerates. Okay? Now they're going to ask us question. Explain the shape of the graph. Explain the shape of the graph. Okay, you take a look at this place, you trace it down. You can trace this one down, then you'll be able to explain. So in the first 8 seconds, see, in the first 8 seconds, the speed of the car is increasing uniformly. The speed is what? Increasing uniformly in the first 8 seconds. That's the first thing you say. You say in the first 8 seconds, the speed, you can see from the first second or from 0 to 8. In the first 8 seconds, the speed of the car is increasing uniformly. It's increasing, it's not constant. Uniformly, it's increasing uniformly, step by step, maybe from 2 to 4, 4 to 8, 6, 6 to 8. That's increasing uniformly. Okay? Now, it's increasing uniformly with time. Now, what it means is that the car is accelerating at a constant, meaning it has a constant acceleration. That's what it means. So you can say in the first 8 seconds, the car is having a constant acceleration, not constant speed, constant acceleration, because the gradient of this is acceleration. So the car is increasing at a constant acceleration. It's having a constant acceleration. Or you say the speed is increasing uniformly. If you want to use the word speed, you say the speed is increasing uniformly, or the car is accelerating at a constant rate. Or you say the car is what? Accelerating at a constant rate. That's in the first 8 seconds. Then, after that, how many seconds? From 8 to 14. If you trace this one down, it's 14. From 8 to 14, that's 6 seconds. So in the next, between 8 and 14 seconds, the car is traveling at a constant speed of 16 meters per second. 14, the car is traveling at what? A constant speed of 16 meters per second. Then, in the last one, which is between 14 and 16, the car is decelerating uniformly. Is decelerating uniformly. Or is decreasing at a constant speed or decelerating at a constant rate. It's up to you how you want to say it. Okay, so that's the explanation for the graph. Now, let's see the next question. It says calculate the rate of acceleration during the first 8 seconds. Now, they want us to calculate acceleration. So acceleration is the same method we did just now. You just find the gradient of this first 8 seconds, which is this line from this 0 point to this point. That's the first 8 seconds, because if you trace this one, that is 8. So they want you to calculate the gradient of these 2 points. What it means is 16 minus 0, which is 16. So you say 16 over 8 minus 0, 60 over at a constant rate of 2 meters per second square. Don't say 2 meters per second. 2 meters per second square. Remember the unit for acceleration, not speed. Okay, 2 meters per second. All these things you have to know. These are basic physics that has been brought to mathematics. You see, they help. They help. If you're a science student, these ones will be supposed to be easy for you. Now let's go to question C. Question C says calculate the rate of deceleration between 14 to 60 seconds. Now let's go to deceleration. Deceleration means when the graph was now going down, this one. You can see it's going to be a negative value, but we may not write negative. The negative shows you that it's a deceleration. That's what negative means. So even if you write it, you don't write it in physics, in maths, it's okay. Okay? But you write it still the same thing. This is decelerating. What the time is what? Only 2. The time is 2. 16 minus 14. Now, what is the value here? 16 minus 0, which is 16, divided by negative 2. Because it's 14 minus 16. Because this is the highest point. This is the one you take first, even on the time axis. 14 minus 16, which is negative 2. Okay, but they may not write the negative. The negative is just telling you it's a deceleration. If not, it would have been acceleration. If it's positive, it's acceleration. If it's negative, it's a deceleration. So you divide it by this, you get -8. But they will not write -8. They will just write 8 meters per second square. They will just tell you the deceleration is 8 meters per second square. So the negative tells you that is a deceleration. The negative tells you that is a deceleration. Is that okay? So that's that. That's that. You get this one, and we're good to go. So every other question you see here, please do. It's easy. Speed time graph, calculate whatever they want. The gradient gives you the acceleration. The area under the graph gives you the distance traveled. If they want you to calculate the distance traveled, what do? You make this one a triangle. You say they calculate the distance traveled by this car. You just say half base times height. The area of a triangle is what? Half base times height. Okay? You use half base times height to calculate the distance travel. Say half base times height. So because this is a triangle. So what half times, what's the base? The base is what's the height multiplied by the height is 6 times 6. Half of 60 is 8. 8 times 6, you get 48, right? So the distance traveled by this guy is 48 meters. The distance traveled is 48 meters. The distance traveled is 48 meters. Okay? The distance traveled is 48 meters. The distance traveled is what? 48 meters. But what if it is like this? What if the graph is like this? What if the graph is like this? If they want you to do for this is a trapezium now. This is not a triangle. This is a trapezium. This is a trapezium. This is not a triangle. Now you employ the formula of trapezium, which is half base, it will be a triangle. Since you start from here, if you join here together, this shape is no longer a triangle, it's a trapezium. So you say half times a plus b. You remember the formula of a trapezium to calculate the distance. Anytime you have speed time graph, okay, this is only applicable to speed time graph. In a distance time graph, no. Half a plus b times height. Now here is a, here is b. A is this distance from here to here, which is 2. This small distance is A. This long distance, which is 5, right? 5 from here to here is B. What's the height? In this case, the height will be this one. The height will be 15. The height will get the acceleration. Now let's move on quickly. So you pause this video and solve all of this one. Pause the video and solve all of these questions. They're easy. Just follow, watch, and understand what we say, and then you will be able to do. Okay, now let's move on to the next segment. Still pause all of this and solve all of these questions. Okay, solve all of these questions on 0. Because it's on 0, this is stationary for speed time graph. But if it's here, it's 0 because it's on the 0 axis. Okay, so pause the video and solve all of these questions. Now we go to area under the graph, we already explained. We go to area under the graph or a speed time graph. Area under the graph is the distance traveled. Okay, they give you value, time and speed value. They want you to plot the graph. You know, once you are given value, you can plot graph, right? You trace time on the horizontal axis, speed on the vertical axis. You trace 0 to 20, trace 5 to 20, like that. So you can see 10 to 20. So the first 10 seconds is a constant speed. So you're going to be a constant speed. So you're going to plot it, look at it. 0 to 20, 5 to 20, and 10 to 20. So it's a constant speed. And then in the other 25 seconds, 27.7, and 30, 30. So if you plot those ones, you get the second part of the graph. You get the second part of the graph. Now let's see, say plot the graph. Okay, we know how to plot graph. Okay, we move to the next question. Say, calculate the train's acceleration in the first 20 seconds. Calculate the train's acceleration in the first Calculate the train's acceleration in the last 20 seconds. Okay, last. Because I was like, oh, first 20 seconds is moving at a constant speed. Acceleration is 0 here. The first 10 seconds. Acceleration is what? 0. Why? Why is acceleration 0? Because it's not changing speed. You can only have acceleration when your speed is changing. If you are running at the same speed, the acceleration is 0. You are not accelerating. It doesn't mean you are not moving. You are not accelerating. You are moving at the same speed. Because why? Because 50 minus 50, even if you are moving at 50, 50 minus 50 is 0, right? Over whatever time it is. Your speed is not changing. It's the same. Initial and final is same. You're moving at the same speed, same value. So your acceleration is 0 at this point. That's why you have a constant speed. Now, in the last 20 seconds, meaning from this 10 to this 30. So we're going to use these 2 points to calculate our gradient. We're going to use these 2 points. So gradient, acceleration, which is gradient, if you trace this one here, what value do you have? 30. You have 30. So we're going to say 30 minus 20. So we're going to say 30. Okay, let's write it outside the graph. So we may need to do it outside the graph. 30 minus 20. No, 30 minus 10. No, minus 20, sorry. On the y-axis. 30, you trace this point, this highest point. You trace it to the vertical axis, you get 30. You trace the second one, trace it to the vertical axis also, you get 20. So 30 minus 20 over. Now you trace them down. Trace this one down, you get 30 also. You get 30 also. Okay, so this one you get 10 when you trace it down. So you say 20 minus 30 minus 10. So if we do that, we get what? We get 10 on the vertical axis in the numerator, and in the denominator, we say 30 minus 10, we get 20, 0.5, or 1 over 2 meter per second squared. Okay, if the units are in meter and in seconds. Okay, so that's what they got here. That's how they got this one. Acceleration in the last 20 seconds of the car. Now that's the first question. The second question says calculate the distance traveled during the 30 seconds. The distance. In a speed time graph, once they say calculate distance, what you do? You calculate area under the graph. There are 2 ways of doing it. You can break it. You can break everything here. As a rectangle, all the way from here, I can call this down part A. It's a rectangle. This whole place is a rectangle. I call here A. Break it into 2. Calculate the area of this one by say length times width. What's the length? From here to here is 30. What's this? 20. So I'll say area of A. Area A. So I'll say area for my A shape is equal to length times width. Length multiplied by width, which is 30 times 20, which is 30 multiplied by 20. Multiplied by 20, that's 600. We get 600 meters. Okay. Then we calculate the area of this one. How do we do the area of this? Here can be our height or our base. It doesn't matter which one is your base. So from 10 to 30 is 20, right? So we call here 20, which is our base. Here can be our height. Our height is from 20 to 30, right? Which is 10, all right? Okay, so we use half base times height. So to get area of triangle, area B, which is area of triangle, is half base times height. So half times the base is, we say 20, right? 100 meters. So total area or total distance travel, the distance travel equals to the total area. Area of this down part, this down part, which is a rectangle, okay, over plus the area of this part, which is a triangle. You add them together. That's 600 plus 100. That's 700. So distance travel is equals to 700. 600 plus 600 plus 100. 600 plus 100 equal to 700. Equal to 700. Okay, so that's the distance, meter. You must put it in meter because it's the distance. And the distance are in meter in this regard. Okay, so this is how to use. So any of this type of problem, you should be able to see the way we shaded it. You break it to A and B because you want to find area under the graph. You calculate the area of this rectangle, which is length times width. The length is 30. The width is what? 20. You get 600. Then you break this one different, you see. From 20 to 30 is 10. And this is 20. You find the area. So you add them together, you get 700. This is how we got this 700. Is that okay? This is how we got this 700. This is how we got this 700. So this is for the triangle, and this is for the rectangle. And the total gives you 700. Is that okay? So you pause the video, solve all of this, plot this graph, answer the questions. They're easy. They're easy. Go to the conversion graph, travel graph, distance time graph, speed time graph. These are all the ones that are not straight line, like curve. Okay, it means you're not moving at a constant speed, or your relationship between your distance travel and time taken is not linear. It's not linear. Is that okay? 4.5. Okay, this one is not 4.5 because you're starting from 1.5. So 4.5 minus 1.5, that's 3. 40 divided by 3, then you get the speed. 40 divided by 3, you see, 40 divided by 3, you get what? You get 4,200 over 3. That's 4.6666. Okay, so you get that as your speed, meter per second. Is that okay? So for non-linear graph, you choose a point anywhere you like on the curve and draw a straight line. And then on your straight line, choose 2 points on your straight line. Calculate the gradient by saying this is a negative gradient because it's sloping this way. You know, if it's sloping like this, it's a positive gradient. If it's sloping down this way, it's a negative gradient. You calculate the gradient. Negative means it's decelerating, means deceleration. So you got to get negative, you see? So you calculate the gradient by choosing this value, 16 over minus 16 minus 0. Okay, 17. This one is actually 17, it's above 16. Because it's choosing from here. 17, trace 17 minus 1, okay, over 2.5 minus 5. Trace this one down, trace this first higher point down, you get 2.5 over 2.5 minus 5. And then you get this negative gradient, which shows a deceleration. Don't worry, negative only shows that the car is decelerating. It reduces speed. Okay, that's the meaning of deceleration. Okay, so now let's take a look at this example. I think this for graphs still on graph in practical situation. And then let's see, and then we plot this graph, we answer question. I think this will be the end of our class. It's circles. Our distance from the start is given by the equation. Our distance is given by this equation, d equals to 0.22 squared. As you can see, this is not a linear graph, where d is the distance traveled in meter and t is the time in second. D is the distance traveled, t is time in second. There's a constant variable here, a variable at the back of this, a coefficient at the back of this variable. And then when you plot the graph, you're going to get a curve. You take the values that you'll be given on the table, okay? You plot the graph, or you choose value 0 to 10. Maybe you're not given the table, you make the table yourself. You choose for time axis from 0 to 10. Then you substitute here, you get the d values. 0 square is 0, 0 times 0.6 is 0. 1 square is 1, 1 times 0.6 is 0.6. Straight line. Okay, so this is what you do. If you want gradient, it's up to you. You can choose a point here, calculate it. Now the gradient of the target to the curve at 4 seconds. Okay, at 4 seconds, it shows your speed was not the same. That's why it's non-linear. Your speed is not the same. At this point, this was your speed. At 4 seconds, your speed was 4.8 meter per second. Okay, 4.8 meters per second, right? Because that's where you choose as your tangential line. And then at 8 seconds, you choose another point of tangent. Choose another point. So when you choose another point here, you calculate the gradient also. You get a different value, which shows you are moving, your speeds are not the same, it's not uniform. So that's why we call it a non-uniform or non-linear graph. That's why it's a non-linear graph. So pause the video and do all these questions, including the student assessment. Solve all the student assessments and for IGCSE. Okay, with this we've come to the end of our today's class. We're showing you questions that you have to do, especially the student assessment is a must. If you want to succeed, solve all student assessment. Assessment 1, assessment 2, assessment 3, do all of them if you want to succeed, okay? Solve all the questions. And if you want to even succeed to get a star, not only solve all the questions, okay? So with this, we've come to the end of our today's class. Thank you for joining us. Thank you.